Dear students, welcome to today's lecture. Today we will analyze complex combination of resistors. That is, we will find equivalent resistance in either series parallel or parallel series circuits. Let's start our lecture. First we will move to series parallel combination. The method of calculating the equivalent resistance of complex circuit is exactly the same as that for an individual series or parallel circuit. Resistors in series carry exactly same current and resistors in parallel have exactly the same voltage across them. It has been conveyed to you in previous lab that in series combination of resistors there is no impact on current. The current remains same across each of the resistors connected in the chain. However, the voltage across each resistor will be different. That is, each resistor will consume its voltage according to its value. The higher the resistor, the higher will be consumed voltage. However, the case of parallel combination is very different. Voltage remains same across each and every resistor connected in parallel combination, whereas current drop across each of them is different. This is the reason why domestic and industrial loads are connected in parallel, so as voltage remains same. The given circuit is an example of series parallel resistor combination. Let's have a look at it. It has 4 resistors connected to a 12 volt source. These 2 resistors are connected in series, which is in parallel with the last resistor. The combination of all these 3 resistors will be in series with the first resistor. Let's go and solve our example. Considering the same circuit, 4 resistors are connected in series parallel combination. Here we have 6 ohm for R1, 8 ohm for R2, 4 ohm for R3 and 12 ohm for R4. Let's try to solve this example. From where you will start? Well, the thumb rule is to start simplifying the circuit from the right side. Here we have right side, else. Generically we can say that we have to simplify the circuit towards source by moving towards source. Like we have to start simplifying the circuit from the right side towards the source. As I already mentioned that R2 and R3 are connected in series, therefore their equivalent resistance will be just summing them up, which will be written in terms of RA R equivalent dash R2 plus R3. So we get 12 ohm as its equivalent resistance. The circuit can now be simplified as this, having 2 resistors in parallel and another resistor of 6 ohm. Now we solve this parallel circuit. As I already mentioned, RA and R4 are now in parallel. Therefore, we can solve it as R equivalent is equal to 1 over RA plus 1 over R4. It will becomes 0.1667. Now, you might remember that this is 1 over R equivalent. So, we have to convert it into R equivalent. For this purpose, we need to reverse it. So, R equivalent or R combination of this parallel circuit will be equal to 1 over R equivalent, which comes out to be 6 ohm. Now, the circuit is further simplified into 2 resistors connected in series. The equivalent can easily be found now as R1 and R2 are connected in series, so we can add them together. Hence, the overall R equivalent of this circuit will be 6 ohm plus 6 ohm, which is 12 ohm. To understand the concept of complex combination of resistors, we now move to our second example. Consider the given circuit having 10 resistors connected in complex combination. Now, you may think that this is very difficult circuit, but actually it's not. You have to start simplifying the circuit through the basic thumb rule of simplifying the circuits. That is, you have to start simplifying the circuit from the right side towards the source. So we started from the right side. Starting from the right side and using simplified equation for parallel and series resistors, we can find the equivalent resistance of R8 to R10 and call it RA. Now we have to solve R8, 10 and 9 first. We know that R10 and R8 are connected in series, which is then connected to R9 in parallel. As illustrated from the figure, these two R10 and R8 are connected in series and both are then connected to R9 in parallel. So we can find its equivalent as RA is equal to R9 multiplied by R8 plus R10 divided by R9 plus R8 plus R10. So it's simplified, our equivalent will be 4 ohm. The circuit becomes simplified as we move 3 resistors into one in terms of RA. So here we have RA and R7 in series and R6 in parallel to both R7 and RA. We have to solve the R equivalent for these 3 resistors in terms of RB as R6 multiplied by RA plus R7 divided by R6 plus RA plus R7, which comes out to be 4 ohm as well. Now the circuit is further simplified and we have now RB and R5 in series, which are in parallel to R4. So we solve it again through the same formula and write its equivalent resistance in terms of RC as R4 multiplied by RB plus R5 divided by R4, 5 and RB. So its equivalent resistance will come as R4 ohm again. The circuit is further simplified to 4 resistors now, in which R3 and RC are in series, which is then parallel to R2. So RD is the equivalent resistance of these 3 resistors, R2, R3 and RC, which comes out to be 4 ohm. The circuit is now simplified into 2 resistors which are connected in series. So we add them up and get our equivalent resistance of the entire circuit. So you see, the equivalent resistance of this circuit is 10 ohm. Now if you would have looked into the circuit before in its original shape, you might thought that this is really a tough circuit to solve. But actually it was very easy to solve, as you need to follow the rules of simplification of the circuits and you get its equivalent resistance really easily. Let's move to the simulation. We will simulate the circuit in Falstad simulator. So let's go to www.falstad.com/circuits and simulate both of these circuits and check whether we get equivalent resistance the same as that of calculation or not. See you in the Falstad simulator. Here we are in the Falstad simulator. We have clicked on the blank circuit. Now we will start constructing our first circuit, which had 4 resistors connected in series parallel combination. So let's start drawing our first circuit. We will go to draw, add resistor and then start placing 4 resistors. So we had 2 resistors in series to 1 resistor in parallel. Here we have placed our 4 resistor. Now we will change its values. First resistor was of 6 ohm, second was of 8 ohm, third was of 4 ohm, and last resistor was of 12 ohm. So we have changed its values. Now what we will do is to connect all the resistors through wire. So we go to draw and click on the add wire to connect all the resistors together. Be sure that you don't miss any of the points, because if any of the points is missed, then you will not be able to find the equivalent resistance. We build one wire here. Now we will connect our ohm meter. So we will go to output and labels and add ohm meter. Here we have added it, and now we'll connect it with the wires. So here we have 12 ohm as our equivalent resistance. It is verified that the equivalent resistance is 12 ohm, which is exactly same as that calculated. Now let's move and simulate our second example, which was basically a complex circuit having 10 resistors. So we go to circuits and then we clicked on the blank circuit to clear the screen. Now we will start building our circuit. So for this we have to click on the draw and then resistors. We will place 10 resistors in almost same configuration as that we had in our circuit, so that we might not feel any difficulty in connecting the points of the circuit. We placed 5 resistors already. It's the 6th resistor. Here's the 7th. Here we go. We have connected 10 resistors. Now we will change its values. Starting from R1, double clicking on it, we will get an option of changing its value. R2 was of 8 ohm, R3 was of 4 ohms, R4 was of 8 ohms as well, R5 was 4 ohm, R6 was 6 ohms, R8 was 10 ohms, R9 was 6 ohms, R7 was 8 ohms, and R10 was 2 ohms. Now we go to draw and place the wires. We will connect the circuit in the same way to avoid any kind of ambiguities. Now our circuit is connected. What we have to do is to take an extra wire right here for the connection of our DMM. DMM means ohm meter. So we go to draw, go to output and labels and pick ohm meter and place it in the middle of these two. So You see, we get 10 ohms here, which is exactly same as that of calculation. So it has been verified that we get R equivalent equal both from simulation and calculation. Now that you are able to do both calculation and simulation, now it's time for your home task. So you have to find the R equivalent as well as you have to simulate the circuits given below. You need to verify both calculation and simulation. Here are both circuits. 4 resistors connected in this combination. You have to tell me which combination this is. Whereas the second circuit is also of 4 resistors, and you need to mention which combination both of these are, either series parallel or parallel series, and how will you calculate its equivalent resistance. This was all about today's lecture. If you have any queries, please feel free to ask. Either you can post it or email. See you in the next lecture. Good luck.